Gonçalves, and our topic is Spanish text classification with BERT. And our research is as part of the Spanish e-learning support project. And the purpose is to collect multiple Spanish resources from the website by using spiders and then classify the unlabeled content by a constrained model for further use. And grabbing a large amount of data on the internet, just like having a data bank. And the next step after this is how to use the crowd data effectively. And after the crowding, the massive amount of unlabeled data need to be classified and processed separately. And this process is just like finding a spam in your emails, and the dataset can be used for subsequent research. And we mainly use two news datasets for our research. The first is called the Newsgate, and it is collected from the cargo dataset, which provides news content by HuffPost, and it was in English. And so we translate it into Spanish with an individual translation model. And the second is which we collect from a famous Spanish news site called El Mundo. And we collect the related news through a recommendation API, and it will outload some related news when you're scrolling down the pages on the exact news. And due to the limitation, we continue our crawling, and we collect for about 10,000 pieces of data. And we use MongoDB for storage and the Scribble framework for the spider. And before feeding into the model, we make the data cleaning process. First, we use the regular expressions to remove marks and symbols in the text. And since two datasets have different structures than shown before, we reform the data into label and content formats. And to meet the model's input and the GPU memory requirements, we apply the truncation to all data and make all sentences under 128 words. And finally, we use the Opus MT model provided by Helsinki University to translate the English text into Spanish. And because we find BERT is such a huge model and we have a limited volume on both datasets, we apply the data augmentation on both datasets with the EDA method, which is published in 2019. And it provides with 4 simple but effective way to augment data. There are synonym replacement, random insertion, random swap, and random deletion. And because this was originally used on the English data, we make 3 improvements on it. First, we modify the source code and we use the standard Spanish stopword vocabulary and the synonym word cloud. And we improve the mechanism for the random insertion and random deletion, because in the original settings, that they do the swap among the sub-sentences. And we find this may do harm to the presentation of the text. So we limited this within the sub-sentence. And then we limited the number of texts generated in different categories. And the amount of the augmented data produced by each case is determined by the proportion of the category in the dataset. So this we can obtain more contents on the low volume categories. And we believe this process can relieve the label embarrassments on the datasets. And then we use the ROBERTA, which is the optimized BERT Pretraining approach. And it mainly with the following improvements: with a larger branch without the next sentence prediction, with a longer sequence and the dynamic mask for the model. And we find the Spanish version from the Hugging Face repository, which is provided by the Schema AI Tech, and it was pre-trained using OSCO's Spanish corpus. And we divided our research into 5 targets. The first, we fine-tune on the raw Spanish data with optimized hyperparameter, and we produce and modify the EDA methods. Then we explore how augmented data improves the model accuracy, and we check whether the translation affects the accuracy of the dataset. And finally, we evaluate the further training efforts and the virtualization. And for the training, we trained the ROBERTA model on both the raw and the augmented datasets to evaluate the improvement of the data augmentation. And at the same time, to detect the impact of the translation on the datasets, we trained the English version of ROBERTA on the raw newscates. And secondly, we trained ROBERTA on the El Mundo dataset, although the amount of data in the El Mundo dataset is relatively small, but it's composed of original Spanish data. We use this step to verify the classification effects of the model on the original Spanish data. And finally, we followed the further pre-training method, which is mentioned in the paper, how to fine-tune BERT for next test classification. We use the newscate model, of which obtaining the first step to train the El Mundo. And the step of the news case is regarded as the further pretraining to improve the understanding of the news domain information on the El Mundo dataset. And we use this step as a validation. And here's the results. In the first table, you can see that after the augmentation, the accuracy on both train and the valid sets are improved significantly. And we find augmentation may do a lot of help for the training. And then for the Spanish version and the English version, there's not too much difference. So the translation is not doing too much harm to the accuracy of the model. And which compare the different setting of the training, and we find that all the models reach a higher accuracy rate. However, the accuracy rate of the model which has been further trained is slightly lower than the second model. And to explore the reason for this retrogression, we analyze the source code and extract the output of each layer of the BERT model, and in general analyze the different layers provides varied language information, and the bottom layers have more basic language information, while the top layers hold more abstract representations. And here we extract the class label, which is in the next zeroth position of the BERT output, which also the input of the MLP classifier, and this determines the final classification results. And for the visualization, we use the MDS algorithm to map the high dimension vector to 2D or 3D presentations while keeping their Euclidean distance between them. We randomly pick up the samples from the datasets and extract the class label outputs. And as can be seen from the figure, that's the class presentation of the two datasets both differed from the original one, and the presentation on the news case is further separated from the original compared to the L model. And we find this difference may be due to the changes or the loss of the semantic information in the original English text due to the translation. And in the model 3, which had been trained twice, and it has a neutral presentation in comparison. And then we divide into the model level to see how the text presentation changes. And for the news case training, the distance of the class labels is quickly separated from the raw model and followed by the continuous fine-tuning in the subsequent stages. And for the L model, the situation is becoming more easy. The class presentation of the model is constantly fine-tuned around the original presentation cluster. And although we can still observe some presentations still moving away from the original ones, but this for minimum should infer that the general presentation obtained during the pre-training is rarely retained during the fine-tuning. And finally, we check the further training process. And as the training progresses, the model's presentation gradually becomes closer to the original presentation. But in the end, it stays between the original and the news case presentation. But note that this result is not caused by the underfitting, because at this time, the model's accuracy on the training sets and the test set is stabilized, and more training steps will not cause the improvements. But we can foresee that the presentation will get closer to the original presentation if we train more epochs. But to verify our inferences, we use the BERT part of the L model to train the news case, which we call the train back. And however, compared to the training on the news case alone, the migration is becoming very soft. And in the end, the presentation space of the model can still be considered related to the original presentation, while it still reach high accuracy in the task. And here for the conclusion, the above experiments fully reflects the impact of the dataset difference in the model presentation. And here 3 models have reached high accuracy in the news topic classification. However, there's a vast difference in the text presentation of the model. And here we should not only focus on the model's performance on the dataset, but also the migration of the presentation during the training. So we believe this may affect the model's adaptability to unfamiliar data and its robustness. And that's all for my presentation. Thank you for your attention.
Very good presentation with good background. I don't think so any questions necessary for your presentation.
Okay.
Thank you very much, sir, for your presentation. Thank you.